All right, so what we're going to do now is we're going to perform a Lambda tune on our liquid level process, first order, because it fits this model right here. So we calculated back in Lab 1, we've determined the first order time constant of our liquid level process, and we also calculated the steady state gain. So I'm going to use the calculated values here. We're going to pretend like we haven't worked with the process yet at all. We're just coming up with some values here based on some stuff that we determined from the process. So the other thing that we're going to assume is that our dead time is probably, there's probably some there. So a safe number would probably be, we'll just use 1, because when we were looking at our trends, when you do the initial step, it's probably about a second before we start to see the process changing. And we're going to select, we want to produce our, we'll go with the slowest, well, no, sorry. What should we use? I think we'll go ahead and use the fastest. We'll use the fastest response here because we just want to save some time here. So yeah, so that would mean that we use a lambda value of 1, dead time of 1 there, and then we're going to use the 2 values that we calculated back in Lab 1 to figure out our proportional gain setting that we're going to use for our controller. And then we will be using our first order time constant as our reset time. So just to show you, we're using the same process here again. I haven't turned the pump on or anything, just to keep down the noise a little bit. But if we go back over here, we've got some values here. We'll just get rid of those for now there. And then set these both to some low values here. And actually I'll put this one really high. And what I'm going to do is, this is where I'm going to key in my gain and reset value that we calculate there, the KP or the proportional gain, and then the TI or the reset value that we're going to key in there. We're going to calculate those, key them in. What I'm going to do is I'm going to let you guys figure those out on your own, and then I'm going to key the values in here, and we're going to see how the process responds to set point change when we use the Lambda tune here. All right, so I have our Lambda tuning values entered. It's holding steady at 50% right now. You can see over there, level in the vessel is approximately 50%. So what I'll do now is I'll give it a set point adjustment here. We'll go, we'll try going down this time. We'll go down to 30. 30% will make a fairly drastic change here. And so you can see the controller output dropped off there right away. And it's slowly dropping down now. If we look over here, you can see the level in the vessel is dropping over there. And now what we'll do is we'll just have a look at the trend here. What we should have is fairly minimal overshoot happening here. You can see the controller output there coming back again, and very minimal oscillation. And that's kind of what that Lambda tune is after, is to kind of minimize that oscillation. Whereas the Ziegler-Nichols will do the quarter amplitude decay. That's the goal there. So it looks like the tuning parameters will work quite nicely for a quick response. We went right down from 50 down to 30 with minimal overshoot. Maybe what I'll do is I'll just go back the other way, because it will react a little. The flow in will be faster than the flow out of the vessel likely. So we'll just see how it reacts to a set point change in the other direction here. Looks like we did have a small overshoot here, but that's what we went for, was the fast response. And it looks like very little, no quarter amplitude decay, kind of just an overshoot, and right back to normal. So it looks like if we did want to guarantee no overshoot, we would have had to select that lambda value of 3, and that would have made sure that we didn't have that little overshoot. But so it looks pretty good.